So you can see that we are trying to trade off in cluster analysis. We are trying to trade off between reducing complexity and retaining the diversity that exists. So let's take our data set, and of course it's a handcrafted data set just to illustrate the point. So you've got the age and height and you've got all the different points. If you plot the age and height, you see the points are here, some points, and there are some points here. Okay, so clearly you can say, well, I will put all of these points in one cluster, put all of those points in another cluster, right? Because these are all quite similar to each other in the sense that they all have somewhat high values of age and height, and these are different in the sense they have lower values of age and height. Okay, so instead of treating them as 12 different individuals, you can say, well, that's the group of big kids and this is a group of small kids. Okay, so you've divided them into two clusters. So if we go back to the example of assigning a coach, might be a good idea to assign one coach to that group and another coach to this group, rather than to assign one coach to the entire group, because there's going to be quite a lot of difference between these two people. But the people inside each cluster are likely to be quite similar to each other. Okay, I'm not saying they're exactly the same, but that will be more manageable than if you try to do the whole thing as one group. Okay, so what we are saying is, if you break it up into two clusters, then you can think of the entire data of 12 people as represented by the two averages, right? So for example, X represents the average age and average height of that group of people, right? The average age, average height of that group, and Y represents the average age and height of this group, right? So rather than seeing this group as 12 different cases, in the clustered solution, we are now seeing the case as 6 cases of X and 6 cases of Y. Okay, so in the original data, we had 12 different cases. Let's say the complexity was 12. In the clustered solution, the complexity is only 2, because you're viewing the data as consisting of 6 cases with this average age and height and 6 cases with this average age and height. So you've reduced the complexity from 12 down to 2. Okay, of course, we need to think about how much of the variety is still retained in this, right? Obviously, there is some loss of variety, right? Because you're not accounting for the differences among all these people. You're just saying, well, all of them are the same, represented by this. Again, here too. Okay, so clearly there is some loss of diversity or variety in this model, but it also does manage to retain some variety because it's saying this group is different from this group, right? It's not completely sacrificing all variety or variability. So if you look at the cluster, there are two clusters consisting of 6 people each. The first cluster looks like that, the second cluster looks like this, and the average age of the first cluster is 9.78, the average height is 53.62, and so on. Okay, so the data, instead of being represented by 12 different points, is now represented by 2 different points. One point is this, the other point is this. Okay, so these are the averages within each cluster. Now, there is no hard and fast rule that says you have to look at it as just 2 clusters. You may say, well, what if I look at it as 3 different clusters? Right? Put these 3 in one cluster, put those 3 in one, and leave those aside. So there's no laid down rule that says how many clusters you should have. It's a subjective decision to determine, okay, how many look good for me. And I will shortly give you a mechanism by which you can arrive at that subjective decision. Okay, there is no right answer to that problem. So one thing we would like, of course, for every cluster, after all, as we look at this diagram, one thing we are trying to see is a cluster is a good cluster if the points in the cluster are all quite similar to each other, right? So if you've got a cluster in which the points are all over the place, then the middle value in the cluster is not really representative of all the points, right? So ideally, we would want the clusters to be highly coherent, which means the extent to which the cases in the cluster are similar to each other. Okay. And of course, what is the cluster with the highest coherence? The highest coherence you will get in a cluster if all the cases in the cluster are identical to each other. That would be a perfect cluster, right? So an example is shown here: age 10, height 53, age 10, height 53, height 53. There are 4 cases. All of them have exactly the same age, exactly the same height. So that's a really coherent cluster. Of course, we will not find such clusters in the real world, but that's an example. It just serves to help us to understand what we mean by coherence of a cluster, right? So we want the cluster to be as homogeneous as we can make it. Or put it the other way, we want to gather all cases which are very similar, put them into one cluster. And cases which are similar among themselves, but quite different from cases in the first cluster, put them into a different cluster, and so on, right? So we want to create clusters which are nothing but groups of highly similar objects. Okay, so how will you get the highest overall coherence? Overall coherence in the sense of for the entire data. Okay, you break it into a certain set of clusters. What is it that's going to give you the greatest coherence? Well, you'll have that when you create only perfect clusters. And we already know what we mean by a perfect cluster, right? So in this case, what does it mean for us to create a perfect cluster? Well, if you create a perfect cluster, in this case, each case would belong to its own cluster. Okay, so that's one cluster, that's another cluster, and you'll end up with 12 clusters. So theoretically, you have highly phenomenally coherent clusters because every case is its own cluster, but it's useless in practice, right? Because the purpose of cluster analysis is to try and reduce the complexity. But if you put every case in its own cluster, you have not touched the complexity at all. You started with 12 cases, now you have 12 clusters, nothing has been achieved. Okay, so therefore, when we do cluster analysis, we obviously have to be willing to accept some amount of imperfection in the clusters that we create. We're not going to have clusters in which all the cases are going to be totally identical. That will never happen, right? After all, imagine you have 10,000 customers. You want to cluster them into, let's say, 10 clusters, right? Obviously, all the customers in a particular cluster are not going to be identical to each other in all attributes. They're going to be different, but by and large, they're all going to be quite similar. That's what you're going to look at. Okay, so what we are looking at, one extreme is put all the cases into one cluster, which is the one size fits all approach. The other extreme is treat every case as its own cluster, which is the complete customization aspect, right? This is not useful because it's one size fits all. You're missing the diversity that exists in the group. This is not practical. If you could do this, fantastic, but no organization can do this. Therefore, what we are looking for is the middle ground, right? We are saying, okay, I will take a few clusters, I'll put many customers or many objects into each cluster. Among themselves, these are all very similar, but across the clusters, there is discernible difference, right? So what you're getting is you're retaining some amount of variety by recognizing the fact that the clusters are indeed different. And we are also reducing the complexity by saying, okay, I'm going to treat all the cases within a cluster as pretty much similar, right? So you're reducing the complexity from, let's say, 35 cases here to just 3 cases, but you're still managing to retain some of the variety or some of the diversity. Okay, so the main trade-off that's being made is you want to reduce complexity, at the same time you want to retain some diversity, right? Which is why we cannot go to one extreme or the other extreme. We are trying to find a middle ground.